In this tutorial, we're going to learn to solve rational equations by multiplying through by the least common denominator of all the terms of the equation and then solving. Once we have the solutions, we're going to check to make sure none of the solutions are extraneous, which means that they are not omitted from our domain. Before we divide or multiply through by the least common denominator, though, I want to make sure that we understand what a least common multiple is, which is how we're going to get our least common denominator. So what I asked is, what's the least common multiple of 6, 9, and 12? And the first thing I did is I just wrote out the first 10 multiples of each of these numbers. In order to be a least common multiple, it has to be a multiple of all three of the numbers. So I look for a value here that is a multiple of all three numbers. The first one I come to is actually going to be the smallest. Notice that 36 is the least common multiple of 6, 9, and 12. There is another way we can come up with the same answer, though, and it's going to be a lot more helpful when I start to work on these rational functions. So let me show you another way to find the least common multiple of these three numbers. And I'm going to do it by breaking all three of these numbers into prime factors. 6 I can break into the prime factors of 2 and 3. 9 can be broken into primes 3 and 3. 3 times 3 is 9. And 12 can be broken into primes 2 times 2 times 3. Now if I'm going to be a multiple of these factors, I have to have all of the factors, a multiple of these numbers, I have to have all the factors in. And so I know in order to be a multiple of 6, I'm going to have the number 2 and 3. But now that 6 is already part of this common multiple, in the other factors I can get rid of 1, 2 and 1, 3. So I can get rid of the 3 and the 9. I don't have a 2 to get rid of. I can get rid of a 2 and a 3 in 12. However, the other factor of 9, is the 3 has not been taken care of, so I need to put it in also. Down here I write a 3. That gets rid of the 3. But I still have a 2 for 12. I put it down. Now I've taken care of all the factors that I need, so my product should be my least common multiple. 2 times 3 times 3 times 2 is 6 times 3 is 18 times 2 is 36. Sure enough, my least common multiple is 36. And we're going to use that idea to find our least common denominator for these next few problems that we're about to do. All right, equation 1. X plus 3 over x is equal to 4. The first thing I want to do to make sure I don't miss my extraneous solutions is to find the domain of possible solutions of this equation. This is a rational function. The only thing I really have to worry about in rational functions is division by 0. Now, is there any value for x that would cause me division by 0? And sure enough, there is 1, the value x. If x is 0, or the value x in the denominator, if the value is 0, I have 0 plus 3 divided by 0. Well, that's undefined. And so I know my domain of possible solutions is every number except 0. If 0 becomes an answer later on, I'll know it's extraneous. Now next, what is the least common denominator? Well, I'm going to rewrite x as x over 1. I'm going to rewrite 4 as 4 over 1. And then I look at my denominators. I have 1, x, and 1. So 1 has to be a factor. I can cross out the 1's. X has to be a factor. That takes care of everything. My least common denominator is just going to be x. So what does that tell me to do next? Now I'm going to multiply through the equations. So I'm going to learn how to actually erase this in one fell swoop, but that's for another lesson. I'm going to multiply everything through by x. Remember, I've got x over 1 plus 3 over x is equal to 4 over 1. And so now I multiply everything by x. Here's an x, here's an x, here's an x. When I do, I get x squared. The x's will cancel out here. Remember, x can't be equal to 0. Plus 3 is equal to 4x. There's a resulting equation obtained by multiplying both sides of the equation by the least common denominator. So I've got x squared plus 3 is equal to 4x. Now I need to solve. I'm going to solve a quadratic by putting everything on one side of the equation and seeing if I can factor. So using x squared plus 3 is equal to 4x, I'm going to rewrite as x squared minus 4x plus 3 is equal to 0. Well, I can rewrite this as x minus 3 times x minus 1 is equal to 0. Hopefully we can factor. If not, we need to go get some more factoring practice. Now, if I have a product equal to 0, one or one or the other factor has to be equal to 0. So either x minus 3 is equal to 0 or x minus 1 is equal to 0. This tells me x is equal to 3, and this tells me x is equal to 1. So my answers are x is equal to 3 or 1. Now, are either of those answers restricted by the domain? No, the only answer restricted by the domain is 0. So unless I did something wrong, that should be my answer. If you plug it back into the equation, you'll get 3 plus 3 over 3, that's for checking the solution of 3, is equal to 4. Yes, 3 plus 1 is equal to 4. To check my solution of 1, I get 1 plus 3 over 1 is equal to 4. And sure enough, both of these are good solutions. We're going to use the same approach for the next two problems. 2 minus 1 over x plus 1 is equal to 1 over x squared plus x. Well, this time I have to do a little bit of factoring first. So I'm going to rewrite this equation as 2 over 1 minus 1 over x plus 1 is equal to 1 over, well, if I'm going to factor x squared plus x, the first thing I always look for is a common factor. There is a common factor of x. I'm going to factor that out, x, and I'm going to be left with x plus 1. Let's try that out here. X, ran to the end of my board there. X plus 1. Still ran to the end of my board. Hopefully you can see that. Okay, now, what is my least common denominator? Well, in the first expression, I have just 1. Then I have an x plus 1. Clearly the 1 I don't need, so it's x plus 1. The third one is x times x plus 1. So when I look at my least common denominator, I'm left with x times x plus 1. Let me rewrite this over here to make sure you can see. So I've got 2 over 1 minus 1 over x plus 1 is equal to 1 over, and I'm going to leave it in factored form, x times x plus 1. And we're going to multiply through by my least common denominator, which is x times x plus 1. So I'm doing x times x plus 1, and x times x plus 1, and x times x plus 1. Why'd the middle one go in parentheses? Because I get nervous when I make these tutorials. Multiplying through, I get 2x squared. The 2x times x is 2x squared. 2x times 1 is plus 2x. I can cancel out the x plus 1s, and I'm left with minus x is equal to, I can cancel out the x's and the x plus 1s, is equal to 1. Okay, so remember my least common denominator was x times x plus 1. The resulting equation is going to be 2x squared plus x is equal to 1. All right, now I need to solve this equation. It's once again a quadratic. Hopefully I can factor, and I actually believe I can. So I'm going to rewrite this as 2x squared plus x minus 1 is equal to 0. And I believe that will leave me with 2x minus 1 times x plus 1 is equal to 0. Let me double check. I get 2x squared plus 2x minus x is plus x minus 1. So 2x minus 1 times x plus 1 is equal to 0. Well, if 2x minus 1 is equal to 0, x is going to be equal to, let me solve it out real quickly. 2x minus 1 equals 0, so 2x equals 1, so x is equal to 1/2. Here, x plus 1 is equal to 0 tells me x is equal to -1. Okay? But What was my domain to my possible equations? I forgot to do it earlier. I better come up now. Look, this is my least common denominator, x times x plus 1. That tells me if I have either of those two terms equal to 0, then I'm going to have an undefined solution. So x is equal to 0 or x is equal to -1 would be a problem, right? My domain of possible solutions is x is not equal to 0 or x is not equal to -1. Well, look, here I've got x equals -1. That's an extraneous solution. I can't use it. And so my only answer that actually works, x is equal to 1/2. One more. Let's see if we can both do this a little better. What is the domain of possible solutions of x minus 3 over x plus 3 over x plus 2 plus 6 over x squared plus 2x equals 0? Any of these factors, let me go ahead and factor out x squared plus 2x. Fortunately, once again, I have a common factor of x, and I can change x squared plus 2x to x times x plus 2. Well, what's my domain of possible solutions? X cannot be equal to 0, and x cannot be equal to -2. Any other solution would work, but those would cause me division by 0, which doesn't work. What is the least common denominator? Well, look, this is x times x plus 2. If I work it out, that is exactly what my least common denominator is, x times x plus 2. What is the resulting equation obtained by multiplying both sides of the equation by that? Well, let's work it out down here on the bottom. Okay, I've got x minus 3 over x plus 3 over x plus 2 plus 6 over x squared plus 2x is equal to 0. And I'm going to multiply everything by x and x plus 2. X and x plus 2, x and x plus 2. Remember, this is x times x plus 2. So my first term, I can cancel out the x, and I'm left with x minus 3 times x plus 2. In my second term, I can cancel out the x plus 2's, and I'll get plus 3x. By the way, when I multiplied through over here by 0, x and x plus 2, I did need to do that also. Not going to leave me a whole lot. Back to this piece here, I can cancel out the x's and the x plus 2's, and so I'm just left with plus 6, and no matter what I multiply by 0, I'm still going to get 0. I have a factor here, x minus 3 times x plus 2, that I'm going to have to distribute. Many people call it FOIL. I'm not totally against that. So x minus 3 times x plus 2 is going to be x squared plus 2x minus 3x minus 6. Then I still have to add these two terms. Plus 3x plus 6 is equal to 0. Well, combining like terms, these 3x's are going to cancel out, negative 3x plus 3x. The minus 6 and the plus 6 are going to be cancel out, and I'm left with x squared plus 2x is equal to 0. So once again, I'm solving a quadratic. I see if I can factor. First thing I look for is a common factor. I have a common factor of x. X times x plus 2 is equal to 0. One of those factors has to be equal to 0. So either x is equal to 0 or x is equal to -2. Let me check that with my domain. 0 can't be part of my domain. -2 isn't part of the domain. Both of those are extraneous solutions. So after all this work, I find out that there is no solution. I hope this was helpful. I should have a sheet with more questions on it to help us. And if I want to give that sheet, I'll also give an answer key so you can get some practice. But this is certainly not the only way that you can solve rational equations, but it's a very effective way by multiplying through by the least common denominator. And I'll see you in the next video.